Hello, it's Keith here, and this is lesson 3 of the Photon series of my Z80 programming tutorials. Photon is of course my little Tron clone. You can see it here if I can remember the controls, which I probably can't. And today we're going to be looking at the random number generation routines and also the routines that draw the title screen. Now the title screen, if we just get back to it by me dying many times, which I'm pretty good at doing, the title screen is made up of a variety of packets and C packets, and we looked at those last time in the line drawing lesson where we covered the line drawing routines. So we're going to learn how this title screen is drawn because it's built up from various bits, and also the random number generation that's used for object positioning and also for the AI such as it is. Let's go over to the code and let's take a look. Okay, so we need to be looking at the multi-platform file here, and we're going to be going through this today. Now, the random number generator is basically the same one as was used in YQuest. It works fine for my purposes, so I have no intention of changing it. I'm in no way saying it's the best. I'm just saying it's what I use and it works. So it produces 16-bit random numbers. You provide a random seed in BC, and it provides a 16-bit random number back in HL. Now, in some cases, we only want an 8-bit value, so we will combine those together to give a single byte, but it can potentially provide 2 bytes. And the point is that if BC is the same, the return will be the same every time. This is intentional so that you can use it for creating predictable levels. If you give the same random seed for level 1 every time, you'll get the same sequence of random numbers back every time. So that can be used to create levels that look like they've been predefined, but actually they're procedurally generated. That's the idea of it. Now, the random number generator has 2 random number routines, one for the low byte, which is a sequence of rotations, and an XOR here that will create a byte from C, and the high byte routine is slightly different. It actually uses the low byte routine as well, and it uses a pair of 16-byte lookup tables, and this was so that the top byte would be pretty random, considering the fact that B wouldn't change most times, because what we do is we increment C after each read. So we needed B to be just as random as C, even though the source hadn't changed since the last byte, because of course we're creating 2 bytes each time. So we're using the lookup tables for the high byte, and we're using the XORs and the rotations for the low byte here. Now, do random will just provide a random number generator. It automatically increments the seed each time. It will read the word, but then it will XOR H with L into the accumulator. So this will give a single random byte based on both randomly generated bytes using the word random number generator. Do quick random word does almost the same thing, although this time we're not combining the 2 bytes together. This is getting a full 16-bit value here. So we have both options just depending on what we want. Now, of course, there will be times where we need a random number within a specific range. I did this in the past with YQuest, but that was doing between 0 and 255 values. This time I needed 16 bits because my screen is 320 pixels wide, and I would need an X position for random objects that you had to avoid in some cases. So what we've got here is a random generator that will then compare the result to BC and DE, and it will only return a value that is between BC and DE. So if it's lower than BC or higher than DE, it will be rejected and a new random number will be generated until this matches. Now, this is basically done by subtraction. We're subtracting BC from HL and seeing if the carry occurs. If it does, then the first value is invalid and the second one shouldn't cause a carry. So we're checking if the value is within the range of DE and BC there. Now, this does pose a surprising problem. Now suppose we want a value between 0 and 500. Now do a quick random word will give a value between 0 and 65535, so we could in theory end up waiting an awful long time before a value comes between 0 and 500, because we only need a tiny part of the range that random generator will produce. And so as a simple solution to get around this, I'm using IX as a mask, and we're masking out bits that we won't need. So what you would do if you needed a value between 0 and 500 is you would set the mask IX to 511, basically ignoring all of the top bits, and then you would do your comparison with these here. So it's just a simple way of making sure that we can get a random number relatively quickly. Of course, you would need to mask out more bits than you needed. You can't mask out the value 500, for example, because of course that wouldn't work, and of course we do need to make sure that there is an equal chance of any of the values within the range we're checking for coming out. So that's how we're doing things, and that does seem to work relatively well. So that's what I'm using to generate a ranged 16-bit random number within the range that we need. Now this is being used by the do X line object and do Y line object routines, and these will produce the random objects for the start of our level. Now if you look at our screen here, basically the players appear here and here, and we need objects in the middle of the screen here. So we're basically randomizing objects in this area here and this area here, basically kind of forming a plus, if you will. Now it's hard to tell because you can't really tell unless you run it many times, but you will never see an object appear here or an object appear here, and that's because the random number generation is designed to avoid that, you know, so that basically so that the player doesn't die as soon as the level starts. So you can see here that we're specifying ranges depending on the screen size, of course. And so the first time here we're specifying almost the maximum screen width but a narrow screen height, and then the second time here we're specifying the maximum screen height but a narrow screen width here, just depending on the screen size, and that is producing effectively random objects in a plus, and these are used by the initialization for the level routines. So we're specifying the range here. We're specifying a mask here of 1 FFF here, which is, as I say, to limit basically the values between 0 and 512. Now, of course, actually the values we want are a much smaller range than that, but that's just to make sure that we don't have to wait too long to get a valid random number within the range that we want. So that's the random number generation. Now next we're going to look at the title screen. The title screen is run as soon as the game starts basically, and it's built up from a variety of packets. Now the title screen objects are all seen here. Some are in C packet format, you can tell there's 2 bytes per line, and some are in packet format, and it just depends how detailed the object needed to be. I think there's actually a duplicate there, you've got Photon twice. Depending on how detailed the object needed to be, I was either using a packet or a C packet just accordingly. Now, if we just have a look at our multi-platform file again, now we have to do various things to define the objects. Now, the objects are drawn at the previous position, and this is defined by locate. So we need to basically start drawing in the middle of the screen. So we're calculating the start position here, and we're moving the cursor to that position, and then we're setting the scale. Now the scale will depend on the objects. Now the C packets are only 7 bits and the packets are 8 bits, but our screen is 256 pixels wide, and in some cases we may need to scale things up. Now a value of 0 means that we're not scaling things up. A value of 1 means we're doubling the scale. So on the small screen, these first objects don't need to be scaled up, but on the larger screen they do need to be doubled in size. So we're setting the scale accordingly there, and we're setting the color to color 2, and then we're going to draw all the objects that are applicable to this setting here. So these are all packets, which means they're using 8 bits per definition. So we're drawing the title here, and that's the background. We're drawing the 3D depth here. I can just show you if I disable this here and then I run the game again. Well, now we've lost the 3D depth of the title there. It's drawn in 2 separate parts for the 2 separate colors. So we're drawing the background of the title there, we're drawing the ball here, the hands of the ball, the eyes, the mouth, and we're then changing the color to color 3, and then we're drawing the foreground of the title. We're then changing to color 1, and we're drawing the tongue. Now these are all in packet format, so these are all using 8 bits for the movement definitions, but some of them are using the simpler C packet format. Now we're then changing the scale. The scale is now going to be doubled up again, so we're now scaling up twice, because these are much smaller because they're 7 bits. On the smaller screen we're only scaling up once here. We're drawing here the diagonal lines of the ball here, that's these things here, and then we're drawing the wall. These are very low resolution objects, so C packet was enough for them. Basically C packet was me experimenting to see if I could save some memory. It's used much more heavily in the font. The font is entirely C packet, but you could have done without it during the title screen, to be honest. Mostly the detail was needed. So that's drawing all of the objects that make up the screen. Now the next thing is the text just here, which is done with our font routine. So we're now setting the scale to small here. So -1 means we're scaling down 1 time here, and then we're using color 4 here. And then what we're doing here is we are going to draw the text, the title, which is in Battle of the Chibi Photonic Hunters. There we go, rather weird title. We like some strange titles. Now on systems like the Spectrum here, the text is all one line, so we've got this version just here. But on smaller screen systems like the Game Gear, this does work on the Game Gear, we've had to split that title up into 2 parts there. So what we've done there is we've drawn it as 2 separate lines, and this is really the benefit of the vector format, is it's exactly the same data drawing both of these, we've just changed the scales. So that was a surprising benefit of the vectors. With the old YQuest, I had to keep rewriting everything. With this, I do not need to. So that's drawing the title here, and then all we've got left is the high score at the bottom, or the best level as it is. It's not quite a high score, it's a sort of high level, if you will, and we're just showing that to the screen. And we're using a show decimal routine here, and that's the exact same one as I've used in the past in, I believe I used that in YQuest. It's the same code. The text drawing routines, print, string, print, char, are the entirely compatible with the previous ones, even though they're now vectors. So that's a bonus of the way of doing things here. So there we go. That's actually all I'm covering today. Quite a short lesson relative today, and the last one on the line drawing was very long, so this one's a little bit simpler. But anyway, that's all I wanted to cover. We'll be coming back later with some more of the multi-platform code, and we'll be going on later to the platform specific stuff, the pixel drawing and all of that kind of fun stuff, because in some cases it's quite different. The Sega Master System is using MSX1 compatible drawing routines, but the Game Gear can't do that apparently, so I had to use a completely different format. But then the Game Gear had enough tiles to draw every pixel of the screen different, so I did do. So yeah, very interesting stuff, lots of fun. Anyway, hopefully you're going to stick around for that, because I think it should be quite fun. If you've liked what you've seen, please like and subscribe. If you like the videos, YouTube might recommend them to more people, which will help me out. And if you subscribe, it just generally encourages me to keep going doing this, because it's a lot of work. You know, it's I'm spending my Saturday evenings in making videos as usual, and I spend most of my week in writing tutorials. So it's a lot of work to keep this up, so that would help me out. Anyway, whatever you do, I hope you enjoyed this video. You can get the source from the website and play around with it to your heart's content, do whatever you want with it. But whatever you do, I hope you enjoy your Z80 programming. Thanks for watching today, and goodbye.